Hello, everyone. Welcome back to the AAS YouTube channel. And this one is going down the Scientific Editors series. So you get to meet your scientific editors. And I am super happy to have the Planetary Science Journal scientific editor, Rivera-Valentin, with us today. Hey, Ed.
Hello. How's it going?
I am doing very well on this August 27th of 2021 in Phoenix. And where are you at, Ed?
I am in very, very warm and muggy Houston, Texas.
Oh, yes, especially in August. That Gulf moisture is rolling up.
Yep, it is.
Oh, wow, very cool. But it should be ending soon, right? I mean, come late August, usually typically September is when those tends to shift and you'll lose some of the humidity. You don't look too optimistic on that.
No, not really. Luckily, I'm used to it. Since I'm from Puerto Rico and it's always humid constantly, it's not that bad here. It's just still
the combo. So
yeah.
Puerto Rico, that's cool. Did you grow up in Puerto Rico? Did you grow up in the quote shadow of that awesome background picture you have?
Partially. So I was born in the city of Arecibo. And then my family, when I was about 6 or 7, ended up moving to Pennsylvania. So, but then every other year, we pretty much would always fly back, see family.
Cool. Well, I like that picture, and hopefully one day we'll get a version 2.0 of
yes,
that.
AO 2.0.
Yeah, 2.0 on that dish coming back up. That'll be awesome.
We definitely need it.
Yeah, I think we do. I think they're making a really good, science case on why it should be returned and even better than it was before. So
yeah, we have the technology. We can build it better, faster, stronger.
Oh, that dates you there, Bionic Man.
Maybe.
And it'd be a little bit more, the $6 million man doesn't, 6 million, we got to move into the billion or trillion at this point, so inflation happened since the 70s. Very cool. Ed, what do you like to do for research?
My research is kind of random in a sense. So I like to do things that can be applied to 2 general fields, one of them being planetary defense, because obviously Arecibo. So with that, I study near asteroids with radar, try to characterize them to the point that if we need to mitigate them as a hazard, we have the information needed to actually do that. And then the other aspects that I like to do falls under planetary protection. So that's understanding where are there habitable environments outside of Earth. Okay. Where can terrestrial life actually persist if we sent it to Mars, for example? For that, I look at brine stability, how brines form, how long would they last, what is their chemistry and their temperatures, and compare that back to all the tolerances we know of extremophiles to say then, yes, if you send a mission there, you need to be extra careful because this life form might be able to use that water. So in general, those 2, planetary defense and planetary protection, put together, I know they kind of sound very separate. I like to say that I study life. I like protecting life on Earth and protecting life outside of Earth.
Very cool. Sounds like there's a little bit of a mix of geology in that, right? Geophysics.
Yes.
You're doing
100%
stuff like that. Cool. So I'm always curious how people get into the research fields they do, right? Because there's 1,000,001 different topics one could do within planetary science or astronomy larger. And so how did you get into this topic?
This is such a long story. So generally my love for science started because I was born here, right? So my parents taking me up to the observatory, I was like, that's super cool. So my inspiration to pursue science was Arecibo. Then when I went to undergrad, I went to undergrad for physics thinking that I would go into astronomy and astrophysics. But while in undergrad, I was in the honors program, and there you get to take a honors seminar every semester. And those seminars are, most of the time, they're very random topics. Like one of them I took was the Tao of physics. So understanding the intersection of philosophy and physics. They actually had one about how to make fear. But the one I took that inspired me to go into planetary there was one offered on planetary geology. And we went through the solar system and studied the type of data we're getting back from missions and what's that teaching us about not only the processes on the planets, but how all these planets ended up forming. So seeing that high level data, and like we could send missions to places that are far away but still close and get high resolution data, that got me into, maybe planetary is kind of what I want to do. Later in undergrad, I got to do an internship at the Lunar and Planetary Institute, which is where I currently work at. And there I got to do a really nice project doing crater counting, but it's more than just going one crater, two craters. It's you're looking at the morphology of the crater, their sizes, their depths, how they look, or do they look degraded, or are they looking fresh? And taking that with a statistical approach to kind of be able to backtrack the ages of some of these icy moons. And there, I think, is where I really fell in love with the planetary, because underneath everything, I love math. I am a stats geek. Math and stats are like one of my loves. And being able to apply that and get a really neat story out of this icy moon with all these stats, I was like, okay, this is definitely what I like to do.
Cool.
So for that, when I went to grad school, although I had this background in stats and doing crater counts and geology, when I got there, the programs, there was an opening for a modeler. The program I went to was primarily an experimental place, but they didn't have someone who would be able to take the experiments through theory and modeling and then apply that somewhere else. So when I got there, they were like, oh, you do math, great, here, go do this.
Very
so
cool.
That's how I ended up doing what I do now.
That is so awesome. That's a great story. Thank you for sharing that. That's wonderful.
A bunch of random roads.
Well, not too random. Varied is how I would describe it.
Yes.
So what was your very first article in AJ or APJ or something like that? It's one of the AAS journals.
So my first paper, it was an AppJ.
Wow.
And this one, dude, a long time ago. Time is an illusion. Not 19. I'm not that.
Well, you were referencing the $6 Million Man, so you know.
Maybe. No, I think my first AppJ was 2012, 2013, around there.
Very cool.
So that project was, it's a good example of the type of stuff I like to do. So it concerned Iapetus, a moon of Saturn. Oh, yeah. It's a really cool moon in that like one side's really bright, the other's dark.
Right.
But it's also like this nice walnut shape, because right at the equator, it's this nice ridge. And so when we were studying the ridge, we noticed that it still had a lot of really nice, pristine peaks. Yet this ridge is supposed to be the oldest thing on Iapetus. So how did it retain pristine peaks with all the impact cratering happening and be the oldest thing? Right. So what I did is I took the geology of that ridge and also the crater counts around Iapetus. I put that together through an impact code that brought in like the different types of solar system formation models. So feeding in a planetesimal disk mass, feeding in the different types of orbits that each of these impactors would have taken in these formation models, fed that in, and then said, all right, now you hit Iapetus. Which one of you gets closest to it? And what should be the planetesimal disk mass so that Iapetus still gets all the craters it has and then still able to retain the ridge with the segments that are nice and pristine. And so that fed back, and we were able to say, okay, this model doesn't really work. This other solar system formation model, the NICE 2 at that time it was called, that one works really nicely, but we need to reduce the planetesimal disk mass a bit. Okay. And we also found that that number actually corresponded to an earlier study that took the number of asteroids in the Jupiter Trojans, and they fed it through the same NICE 2 model, and they were able to find, in order for you to have the number of Jupiter Trojans, the planetesimal disk mass would have been, I forget the actual number because it's been a long time, but it would have been X number, and that's exactly the number I got on Iapetus. I was like, hey, this thing works now, yay! Awesome.
We will put a link to the Ed's first APJ paper in the description below the video, so check it out.
It's a fun read.
You're going to find a sudden burst of citations all of a sudden.
Finally.
Very good, very good. So time went on, and I imagine that was not your first AAS journal article. And so time went on, and at some point, you decided to become a scientific editor for the PSJ. And why was that? Why did you decide to become a scientific editor?
So for a while I've been advocating in Planetary that we needed a journal that fully represented our community, that a planetary geologist could submit to a planetary geochemist, a planetary astronomer, an astrobiologist,
Yep.
the people putting missions together. It was one journal for our community. For a while, because for a while there, we had some journals, but they focused on the geology aspect, or some that focused on the physicsy aspect, or some always had a community perception that they focused on different aspects. But we didn't really have one that was fully encompassing our community. So once PSJ came about, I was one of the first people going, "Hey, Faith, I hear PSJ's around.
Very cool.
Can I help?"
You were proactive. You went after it.
Yeah, it'd be cool.
Well, that's good. Good. It's good to hear that you were actually proactive and wanted to do it, as opposed to, being, some Shanghaied or something like that, dragged off. Here's your penance for writing this terrible paper. You're going to be a scientific editor for a while. That's cool. So, what does a PSA editor do? Since
I see your jobs more. Great. So I see your jobs as like, Diana Troy from Star Trek. I see your job as being Diana Troy.
Okay.
Because we're the people who stand there between a bunch of people trying to talk to each other who don't actually see each other. And we're just trying to make sure that communication works seamlessly. Cool. So once we get a paper, typically Faith has already done like the first filter saying like, oh, is this paper worthy to go out to review? So by the time it gets to me, I'm like, I already know it's in scope and there's no fundamental flaw behind it. It's worthy to be reviewed by somebody. So then I read it and I say, what type of reviewer is needed for this? Because it is planetary, most papers come in and they'll be putting together something about geology with something about biology, tying that together. So you would want a reviewer that knows the geo, and you want a reviewer that knows the bio to actually understand and fully review and assess the paper. So then I'm that person going, all right, I think I see the two or main topics of your paper. Let me try to identify community members that can help you make this stronger. And then I just facilitate that conversation.
Yeah, and PSJ requires two reviewers, right? So
yep.
In that sense, it's a little different than, let's say, the APJ or AJ, where usually it's one, but two is not necessarily uncommon either. I would say in my own scientific editor stuff, probably somewhere around between 5 and 10%. I'll go with two referees for various reasons, but for the PSJ, it's required to have two reviewers.
At least two reviewers.
That's right.
There are sometimes I go to 3. Mm-hmm. There was actually a really cool paper where they were applying this new machine learning method to Planetary. Mm-hmm. And the person who invented it works at Google and had only applied it over to Google stuff. This thing had not been applied to something outside of that. So I found 2 science reviewers, and then I sent also the paper to the person who invented this technique going, do you think this is a proper application of your technique? And they were actually super happy to review it because they're like, somebody else is using what I just did? Oh, and they did it right and it works, okay.
Very cool, very good. Okay, let's see, the unique thing about the PSJ is that it's gold open access, right? So what does that mean?
So gold open access means the moment people's papers are accepted and it gets prettified through our publisher, it gets posted online, it is free to download immediately. So there's different levels of open access, right? There's it will be online, but there's a paywall, but the authors can submit their papers to a public repository. That's level 1. Then the next level is it's online. Sure, the authors can also put in a public repository. There's a paywall, but there's like a 1-year waiting period and then it becomes free.
Right.
And then there's us at gold open access. Like, sure, if you want to put it in the archive or another public repository, you can. But in any case, the moment it's up, it's free. You can download it. There's no limitations.
That's great. That is a very nice model. transparency of the science, right?
Exactly.
So it's a great way to go. How long has PSJ been operating now? Maybe a year and a half?
I think we're moving on to a year and a half now.
Very cool. Very cool. So in a given week, let's say, roughly how many new manuscripts do you deal with as scientific editor?
So I did this math this morning because I always feel like it's a lot. And so I just wanted to look at an average. So today I actually accepted my 125th paper.
Wow.
It was cool, right? I have like, I think in total, so there's for sure accepted 125. Then there's obviously papers that are back with authors, so they're waiting. There's papers with review. Right. You add all of that up and divide it by the weeks I've been working, it comes out to something like about 5 papers on average per week. And I'd say I'll fluctuate between none to maybe 10, 15, but that 10, 15 is rare. It's 5 makes sense. Yeah, we have several focus issues in PSJ, yes. And every now and then we'll get an influx of just papers for the focus issue, and it's like, great, 15 papers.
Can people suggest focus issues?
Yes, 100%. So the way you can suggest a focus issues, you just email our lead editor, Faith Vilas, and say, hey, I want a focus issue. This is my general idea. And pretty much that's it. And then we just put it up online and we'll start collecting papers for it.
Very nice.
The one thing I'll add about focus issues that we do compared to like special collections and special issues that other journals do is the thing I like about how ours works is we don't collect the papers and hold on to them and then release them together. Oh, the moment they come in, they immediately get posted into the special web page for that focus issue. Got it. So if you have, as always, there are some people that end up needing more time to write their paper or more time to go through review. That is not going to hold up your focus issue. It will go online immediately.
Sure. Otherwise, it's like herding cats. Everybody trying to get in.
Exactly. Yeah.
Okay, so you get these new submissions in, and you give them your initial read, get your initial take. And so, what do you think makes for a good initial submission coming in?
So I think what I tell people that have asked me this is I think we all need to be careful in our editing of our papers, in that make sure your spelling and your grammar and your collection of sentences make sense and you're communicating the science appropriately. Mm-hmm. That you didn't miss maybe a Site P error and now there's question marks instead of the reference. Yes. We think this is something obvious, but we've actually gotten, as a reviewer myself, I've reviewed papers that come in that still have those errors and still need a lot of editing besides the science aspect. And the bad thing about that is that if it goes out to review, the reviewers will focus in on that instead of trying to improve your science. Right. Do that first pass edit.
Yeah, make it clean. Have somebody else read it.
Exactly.
Okay, so you got one that's clean and hopefully clear and got some science. Then it goes out for review, and there's the process. So do you have any tips for authors about the review process? Anything you want to say to authors?
So I as a person who also writes my own papers, I completely understand that when you get the review reports back, sometimes our first reaction is to get defensive when we're reading this and go, oh, they obviously understand, how dare they? What I think the best advice when you as an author are reading reviewer reports is, one, understand that the review process is meant to help you identify any potential flaws that you have in your paper and help you identify areas where you weren't able to communicate your science effectively. Yep. So if you got a review back and the reviewer said, I think you said this and this is wrong, and you're like, but I never said that. Don't get offended and take it, I never said that. So take that as a message of, I need to clarify what I'm trying to say. I need to clarify how I'm saying it because I didn't effectively communicate with you. So we need to, one of the tips that I personally do is I'll get the reviewer report and I'll read it once. My brain will go into defensive mode because everybody's brain goes into that mode.
Sure.
Then you put it down and wait like 2 or 3 days and then read it again and read it in segments and then go, oh, I obviously need to clean up the language here. This didn't come through. I need to fix this part. This didn't come through. Because it's all just about making our science more and effectively communicated with others. Awesome. And cleaned up, because we're humans. We can make mistakes.
Yes, we do. Well, we'll have to just build one better and stronger and faster, and we'll just make
exactly
the ultimate scientific editor. No, that was very well said. Yeah, I would agree. I think, you know, in 99% of the cases, it sounded really good when you wrote it, or it looked good, but when somebody else reads it, they're going, what? And then they might misinterpret it. And so, you know, 99% of it is communication. You know, most of it is not an error of addition, or, you know, took the sign when you meant a cosine or something like that. Most of it is communication and just clarity of the prose. So yeah. How about on the other side of that, you know, because authors get the report. And so we do have referees, 2 of them in the case of PSJ writing reports. And so do you have any tips or advice for referees who are invited to provide a review for a PSJ article?
100%. So for referees, what I would say is when you are writing your review report, keep in mind 2 things. One, keep in mind that you could be misinterpreting something somebody said. So don't make the assumption that they are wrong. Maybe make the assumption that, what if this isn't clear? So write it in a way that I may be misinterpreting this, but if I read this right, it says this. Maybe clarify this or fix it because it might be an error. If you come at it from that perspective, the author will be less likely to get defensive when they're reading what you wrote. And then that actually helps improve the manuscript. Mm-hmm. And the other tip I'd like to give reviewers is when you're writing it, step away and then maybe like the next day or a few hours later, read it. Yeah. Would you be okay actually receiving this review yourself? Because if not, you probably should not submit it, because that isn't helping anybody.
Right. It's, you know, put the other pair of shoes on, right? Put them in your shoes. Be you okay getting this review? Are you being a nice person, or are you, you know, being a nasty person? So yeah, that's awesome. Very good. Do you have any other tips or advice or anything you'd like to share about the editorial process in general at PSJ?
Yeah, so
or the double-edged
something I noticed during this editorial, I think I've gotten people where they'll submit their papers and then they'll send me an email or a chat saying, hey, I submitted it. Did you get it already? And I learned there that no, you don't get it immediately upon submission because there are a bunch of people behind the scenes who make all of this actually work a million times better, without whom like the entire system would probably break into little tiny pieces.
Indeed.
We have the journal managers, we have the data editors, we have the stats people who look over and make sure that your stats look right. We have the people that look over your figures and your making sure your data is actually easily accessible. And if you have an acknowledgement with a data repository, they check it and make sure everything's working. Like there's a lot of work to look through a manuscript when it gets in before it even reaches us on the editorial side. So one, everybody should know that happens. And 2, everybody should also thank these people because they're amazing. Janice is awesome.
Janice is awesome. Alex is awesome. Greg is awesome. Gus is awesome. Eric is awesome. Yeah, there's a lot of machinery you do, and it's really a value add for the PSJ papers, right? You should be happy that somebody who's got expertise in data or statistics is offering comments on your paper. It's a value add. It's not a negative meant to, you know, put up yet another barrier you have to get through.
Yeah, actually, so a lot of the times where I've seen the stats and the data editors come in, it's been super helpful in that they'll come through because they have a deeper and richer understanding of different stats methods. They'll come in and say, the method you may have applied works, but have you considered this other one, which is going to be probably even more effective and will help you find even more tease out better your data. And then the authors will come back and going, oh my God, that did work. And now I like understand this better. So their help is amazing.
They're helping to improve the manuscript and arrive at publication. Very cool. Awesome. Awesome. Well, Ed, I'm going to wish you a very happy and long life as a scientific editor for the PSJ.
Thank you. Thank you.
Thank you.
And definitely everybody live long and prosper.
And thank you so much for spending, the last 30 minutes or so chatting about your scientific activities. And everyone out there, this is just a chance. If you see Ed, say hi. It's a good chance to reach out to, they're real people doing the scientific editing, and they are your colleagues. And so it's good to meet them and say hello. So thank you so much, Ed.
Thank you.
All right, everyone, that'll do. And I hope this made your astronomy day just a little bit better. And we'll see you on the next one. Thank you. Bye-bye.